So, as I mentioned, we will start chemical properties of haloalkane haloarenes, and which basically mean is how haloalkane haloarenes react in the different situation. So, topic name is chemical properties. In this chemical properties, we have three type of situation. First, you talk about the nucleophilic substitution reaction. How nucleophile substitute your halogen part. Nucleophilic substitution reaction. How nucleophile will substitute our halide part or halogen part. Second, if you use KOH in alcoholic condition, then you will use elimination method. Dehydrohalogenation reaction very popular. It's the fruit. And third, how haloalkane haloarene react with metal. Here we'll talk about the Grignard reagent. Okay. In this situation, we will focus more on SN1 and SN2. Elimination reaction, you will use mainly use KOH in alcoholic condition, and you will have dehydro means removal of hydrogen and halogen, dehydrohalogenation reaction. Here you will have Sirjeff rule, Jetsev or Sirjeff, and here you will talk about the Grignard reagent. हाँ कहाँ हेलो हाँ कहाँ ना एक बार मैं क्लास लेने लगा था 11 बजे फ्री हो जाऊँ फिर मैं आ जाऊँ जमा ज़्यादा जरूरी थी फिर खेत में था कि एक बार मैं बता दियो जरूर फिर उस टाइम में आ जाऊँगा ठीक So these are the main reaction we're gonna talk about in this chapter, and all are extremely important. Example, Grignard reagent not only here in every chapter of other alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, or amine. Every time you will use Grignard reagent one or other way in every chapter. Dehydrohalogenation reaction you have in the 11th class hydrocarbon also. Exactly same reaction given over there. And even by using the same thing, we can also make the alkynes. And every other year they ask question from the SN1 and SN2. So, Rayan, what is nucleophile? Rayan, what is nucleophile?
So I can just scroll up a bit. Elimination part, yes, sir.
Rayan, are you there?
Yes, sir.
What is nucleophile? Nucleophile, nucleus loving. If it is attracting nucleus or positive charge, itself have either negative charge or lone pair of electron. It can be this or it can be this also, where you will not see the negative part but you will see electron, lone pair electron. One of the best key example, if you take chlorine, then chlorine is simplest form of the nucleophile. But if you take ammonia, you don't have charge in case of ammonia. But when you draw the diagram, you will see there is one lone pair of electron. Because of that, ammonia is also nucleophile. Anybody have doubt?
No, sir.
So here we have nucleophile in two versions, whether negative form, very
Sir,
easy to
don't scroll,
identify.
sir.
Yes, Tuhina?
Sir,
I just want to write it, so you explain, so don't scroll at all.
Okay.
Thank.
So, huh, so either with the lone pair or the negative charge. So the simplest reaction in this situation is when your nucleophile attack with the alkyl halide, because we said we are talking about the chemical property of alkyl halide. So one reactant is fixed alkyl halide. So when it react, then it will form nucleophile and halogen will come out. So nucleophile is replacing our halogen. That's why this replacement is known as substitution. And because nucleophile is replacing nucleophilic substitution, if you understand this well, you have really important topic that you can correlate with the coordination compound, ambidendant nucleophile. Sania, what do you mean by ambidendant ligand?
So which have two donor side.
Correct. Same here. When we talk about the nucleophile, ambidendant means dual. Ambidendant means dual. So there are two different center that have extra electron that can act as nucleophile two center. An example of ambidendant nucleophile and ambidendant ligand are exactly same.
So it has more sides, but only one of them is attached. No?
Yes. At a time, only one will donate as a ligand. At a time, one will act as nucleophile. But there are two different options available. For example, if you want to eat, then you can use two hand. But at a time, you will use only one hand. So, use of the hand is also the ambidendant nature. When you are playing football, you can hit with the left leg or right leg. It's your choice, but you have two options. Ambidendant nature. Everybody understood this?
Yes, sir.
Yes, sir.
Yeah.
Yes,
So
sir.
ambidendant nucleophile means nucleophile have two nucleophilic center. Have two nucleophilic center. And without example, you know everything is incomplete. So example are cyanide. In this case, nitrogen can have negative charge, so it can act as nucleophile, or carbon can have negative charge. So carbon will act as nucleophile. Same nitrite, NO2. Oxygen can have negative charge or nitrogen can have lone pair or negative charge. And last, thiocyanate, SCN, sulfur or nitrogen. You know, in your coordination compound, you have thiocyanato N and cyanato S, nitrito N or nitrito O, cyanide, isocyanate, cyanide, nitrite, and thiocyanate. So, it's just quick revision of your ambidendant ligand given in the coordination compound chapter. You can write in the bracket. Same example in case of ambidendant ligand. And either ambidendant ligand, ambidendant nucleophile, or chelating agent. Out of these three, there is a high chance one question will be asked. Out of these three, because sometimes if it is not asked from these two, then it can be your chelating ligand. Also important. Everybody is done with the writing part of this portion.
Yes, sir.
If it is, then we have the most popular topic of this chapter, nucleophilic substitution reaction SN1 and SN2. Jordan, Sarah is there.
So I'll call her. Just call
Yeah.
her. Then.
So first is nucleophilic substitution 2 means nucleophilic substitution bimolecular. As the name suggests, in this case, you have two important molecule. That's why in this case you will have order 2. What does it mean? While you are doing reaction, both the molecule are extremely important. You must have written the SN2 mechanism in this way. Ki you have carbon with 4 structure like this, because we are doing chemical properties of alkyl halide the main reactor. When it react with the nucleophile, then you will have 4 structure. Nucleophile, and then ultimately done. Tell me guys, how many of you know the story that I already told you about this SN1 and SN2?
We know, sir.
Yes, sir.
Okay, Jordan 2, Anvita
Yes, sir.
3, Barinder. Then last year I taught, so Chandana also know. Barinder, I taught in other class because
नो सर मैंने +2 में पढ़ी थी जी।
story. Okay,
So I don't know your story. Your story is like, yeah, based on morals, human morals.
so you don't want my story.
No, it's okay, sir. I'm fine with anything. Your story is also fine.
Okay, so but I will tell the story. The story is, as who don't know, you can focus. People who know, they will find it boring. On moral ground, this is wrong. I agree, but we just want to cook up a story that can correlate with all our concepts. Okay, so here, uh, C is the husband, have 3 children, Chunnu Munnu Tunnu, Chunnu Munnu Tunnu, and a wife X. Hello.
Yes, sir.
When I told you same story before.
I don't remember, sir. I don't think so. Good morning.
Good morning, Sarah. So, Sarah, this is extremely important for you. We are doing SN2 mechanism by molecular, where order is 2 means both the reactant are extremely important for the reaction, and we consider them practically. So, what happened here? We have alkyl halide react with the nucleophile. One transition state will form. This is not intermediate stage. Very important for your exam. This is transition state. This is transition state, not intermediate stage. So I will write no intermediate form. Intermediate means for longer time. Transition, very short time. So it's just time gap. So what is happening in this case? We have alkyl halide in which carbon is husband, have 3 children, Chunnu Munnu Tunnu, and wife halogen, and wife halogen. Now, nucleophile is like girlfriend. We know girlfriend cannot come through the main gate. So, Jordan, what will girlfriend do?
The girlfriend will take the place of the wife's position. She'll,
Backside.
backside, huh?
She will come from the back door. So in this case, we will say that this nucleophile attack from backside. This is important for your NEET concept.
Yes, sir.
One. Second, when this girlfriend is making bond with the husband, then husband wife bond will get weakened with the time since nucleophile is making bond. So there is a formation of bond between the carbon and nucleophile, and husband wife bond is getting weakened. Carbon and halogen. This is transition state. Everything happens simultaneously. Correct? But there is no permanent stage in between nucleophile and husband. So ultimately, what will happen? Bond between the nucleophile and husband will form. Probably they'll get married. Children Chunu don't like their new mother. That's why they stay away from the new mother, and halogen will come out. So this is known as inversion of configuration. Configuration become ulta. Inversion of configuration, also known as Weldon configuration.
So Walden inversion is for this, no, sir, optically active compounds.
Yes, we'll discuss
Only if
about this optical. Yes, only optically active because inactive you will have racemic mixture. Net is zero.
yes, sir.
Okay. So guys, this is the simplest story, but story
The
do not end here.
inversion of configuration, right? So
Yes,
what did you
inversion
write
of.
here?
So what did I write? Configuration, configuration, inversion of configuration. So story
Yes.
do not end here. We have to add some important point. All these happen simultaneously in one step. So a reaction happen in one step, and this point is important. Reaction happening in one step because in next SN1 we will have two steps. Here only one. In this, condition are responsible for this. Like what is the condition? Here condition is maintained by the solvent, and solvent is polar that create division between the husband and wife, but aprotic nature. Okay, so nearby environment is creating the difference. Maybe like husband friends are very bad and they are creating this nonsense. So DMSO and acetone are the polar aprotic solvent that cause SN2 mechanism. Right? Now this is the main reaction. Now we have to create story near the other behavior also like reactivity order. If you see a reactivity in this situation and you take different halogen, so which one will be more reactive? Example, if you take Ri, Rbr, Rcl and Rf, you know, like how many of you watch serials?
Yes, sir.
Do you know this Gopi Vahu Saath Nibhana Sathiya?
Sir.
I used to watch this a lot in my olden days. So, and you must have heard the recent, not recent, 4 5 year ago, there was Rasode mein kaun tha? Kaun tha?
Yes, sir.
Rashi thi,
Yes,
right?
sir.
So there are two people.
Sir.
One is Rasi and second is Gopi Babu. So Rasi is very cunning in nature and nobody can scam her because she is very smart, which is required in this condition. And second is Gopi Babu. She is like when anything happen, and she like cleaning so much that she can clean pistols also, laptop also. And she is very innocent, simple, not aware
So,
about many
okay,
things.
now I realize I was wondering who were the names. Once you said washing the laptop, now I realized who you're talking about.
Do you know?
Yes, sir, she's famous on the Instagram reels. They make edits of her and then that mother-in-law, someone, the old
Yeah, yeah.
auntie.
But the thing is, I used to show you the uh, this. I used to show you the videos. Now I can't because I showed uh, this video where they fall from the pipe between the two buildings. We got content strike
It's a
for
copyright
this.
issue.
Yes, copyright issue. Then I felt ki I can't show you video, especially the famous video on the content, but this I can show you from the other platform. Gopi, wow.
You can show the memes. I think that's allowed, I guess.
Yes, I no 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 not this. रसोड़े में कौन था? I guess this was the रसोड़े में कौन था. Have you seen रसोड़े में कौन था?
चढ़ाकर मेरे पास आई थी तब रसोड़े में कौन था वहां कौन था जब तुम चने कुकर में चढ़ाकर मेरे पास आई थी तब रसोड़े में कौन था
This is
वहां
Rasi.
कौन था
This is Gopi. Oh.
कल मेरी साड़ी पर जूस गिरा था और
So I should
So
show that GJ04TL5539. That was the best.
Why do you have it
yeah.
memorized, Jordan?
No, you know what is the funniest part? Vote chori mein. The one
Hmm.
of the vote registers, the father's name was literally the same number which this Gopi or Kokil or someone had read out in the TV script. Same car number plate was the father's name.
Come to the point. So in this case, Gopi Bahu is iodine. Very innocent, can easily leave whenever told like you have to leave. But RF is like your Rasi, very cunning, but like I won't say cunning, smart because she know how to handle the situation. So in this case, same thing happening. Iodine is bigger in size, can leave easily because iodine is a good leaving group. So reaction can happen faster. Same process of husband and girlfriend happen only depend upon the nature of the wife. Here, iodine is a good leaving group. So easily can leave and reaction can proceed further. But fluorine have very strong bond with the husband. So leaving like in this case, fluorine cannot leave. In this case, fluorine cannot leave. Any doubt, guys? Iodine is a very good leaving group, but fluorine is not. That's why the activity order is this. It can be the size difference also. Like husband is fat and wife is fit, and this they don't have good bonding because of the diet difference. Wife like the healthy diet, but husband like any random stuff. So that's why, in that case, if there is a big size difference, it can easily leave. In this case, iodine is very big, but in fluorine, size is small, so it won't leave. Got it? This is the reactivity order based on the halogen, but not only halogen. We have to also see What is the impact of the alkyl group R part if another part is same? Example, if you see the reactivity order of CH3I, CH3, CH2I, CH3, CH, CH3I, and last this. So halogen is same. Halogen is same. Alkyl part is different. In that case, we have to see the reactivity order. How to decide? It decide the age of the father, like husband, and the children. Example, in case of this, Chunnu Munnu Tunnu were very, very young. So in that case, what will happen? Husband is also young, so they can form bond with the nucleophile. But once one child get older, it means even father is getting older and child can pressurize the father not to do this wrong stuff. Then going further, two children are young enough to handle the father bad act, and now they will block the entry of the girlfriend. In last case, maybe husband is extremely old that no nonsense stuff happen. So tell me guys, in this case, when all the children are old, so husband is older, attack of nucleophile is not possible, so this reaction will not proceed. So based only on this reaction, attack of nucleophile on the husband, you can say in first situation it can happen, in last situation it won't. Anybody have doubt?
No, sir.
So can you explain the tertiary part, sir?
The more the number of children and they are getting older, so steric hindrance is the main factor. Based on the real life story you understood, now the main factor for the reactivity of this is the steric hindrance. Like if the bigger molecule you have, CH3 or any big molecule, they will be crowded around the carbon, so nucleophile cannot enter close to the carbon and can not come close to the carbon for the reaction, for the reaction. Make sense, Jordan? So simplest answer is steric hindrance is the main thing.
So if we have to perform, so basically SN2 reaction doesn't happen in tertiary state.
Yes,
Substitution doesn't occur. Okay, sir.
yes. Because steric hindrance is inhibiting part, like it will stop the reaction. Any doubt?
No, sir.
So based on this whole reaction, we can say that this reaction is second order, so there will be two factors that will be involved in this process. One is alkyl halide and second is the nucleophile. So it depends upon the both the part, alkyl halide as well as the nucleophile. So that's why it is second order reaction. Got it? And your SN2 part is done. SN1 is mostly same. Will do comparison how SN1 is different from SN2, but at the same time story more or less remains same. Only difference is in this situation all the children are supporting the father to do the bad stuff. So in that case, if there are more children, they will support the father and reaction will proceed easily. Second, Here, divorce will happen first between husband wife. There will be first divorce and then further reaction. So divorce is tough and it takes time. So it will be slow step and redetermining step. Why? Because there is high chance, very very high chance, कि during the divorce process, husband wife uh, feel कि no, they are the best partner with each other, so let's stay together. Back reaction can also happen. Otherwise, most of the other thing will remain same. Anybody have doubt? Now tell me how many of you have heard this story, Jordan, except Jordan, Anvita, and Chandana, because these three were last year.
Never heard it, sir. First time.
Yes, sir.
Actually, when I start teaching chemistry, so I start with this story. Jordan, do you remember I taught you even in your 12th class, like you just
Yes,
started
sir.
in NMC also.
Yes, sir.
Huh. So this part is done, guys. Only these kind of question is asked from this. When you are writing SN1, you have to make sure you are comparing SN1 and SN2. Comparison is extremely important between SN1 and SN2, both for board as well as NEET. NEET is more important, but because you should know the difference. As this reaction will be unimolecular. What does it mean? It means in this case, order of the reaction will be one only. So, two difference we already got to know. This is unimolecular SN1, SN2 bimolecular. In SN1, order will be 1. In SN2, order was 2. Here, it depend only on the alkyl halide, not nucleophile. This is extremely important. Depend only on alkyl halide, not nucleophile. Sorry. In this case, if you compare, then your solvent will be polar and protic. Protic means it will form ion. Just hello, hello, हाँ जी, हाँ जी, नमस्ते बुआ, ठीक हो? हाँ जी, उरत क्या कहते हैं, काकरोत्ता है, समझ गया। हाँ, हाँ, हम्म, और क्या बुआ? ना 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 जरूर, ना जरूर बेबे का भी सारा ला देंगे। बस बुआ मैं एक बार क्लास लेने लग रहा था, मैं क्लास खत्म होने आपको तरफ फोन करूंगा। हाँ मैं फ्री होंगे आपको तरफ कॉल कर लूंगा बुआ। ठीक है बुआ। So third major difference is the nature of the solvent. What was the nature of solvent, Tuhina, in case of SN2?
Polar aprotic, sir.
Polar aprotic. There was no ion as such involved in. But in this situation, you will see कि first you are forming carbocation. So it is a protic nature. Polar means electronegativity difference. As such, ion is not formed in the polar nature. But when you are saying protic, it means your solvent is responsible for the formation of ion. That is a very important difference. Nature of the solvent also. Example, here water can form the ion easily as positive or as negative. Alcohol can act like this. Acetic acid can act like this, etc. Okay. Fourth difference. You know SN2, how many steps were involved in SN2, Anvita? Anvita, are you there?
So can you repeat the question?
How many steps are involved in SN2 reaction?
So two main steps, right?
One. Here it will be two.
Sir, I said two only, no?
In SN2, I asked.
Oh,
In
yeah,
SN2,
SN2, my bad. Yeah, SN2 only one step, single step reaction.
here two steps are involved. What are the two steps? First will be the
RDS.
carbocation formation. Carbocation formation, where this alkyl halide will release its X negative ion and it will form carbocation and then nucleophile attack. That's why nucleophile attack is not so important rather than carbocation formation. Got it? Next, Chandana,
So,
just give me a minute. Hello, हाँ रवि, बहुत बिजी हूँ, कोई अर्जेंट बात थी कि? हाँ, बहुत ज़्यादा क्लास लेने आ रहा हूँ, बता। हाँ, 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 मैं क्लास के बाद करूँगा, बस 11:15 से। ठीक, ठीक. Yes, Anvita, you were asking something.
so the carbocation formation is the RDS step, right?
Yes, RDS step is carbocation formation. Chandana, was intermediate formed? There was intermediate formation in case of SN2 reaction?
No, sir.
No, but here intermediate formation occur. Sarah, in case of SN2 reaction, was there inversion of configuration? Sarah, are you there?
Yes, sir.
Was there inversion of configuration in case of SN2?
Yes, sir.
Yes, because children didn't like their new mother. But here, retention of configuration, because children are supporting this act, so configuration remains same and children like their new mother. Retention of configuration. Many other difference because we'll see reactivity order will be ulta. In SN2, Barinder, what was the reactivity order? Maximum to minimum.
So two.
Normal, then primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. So what was the order? Primary, maximum, then secondary, then tertiary out of these three. Here it will be ulta. Ulta means tertiary is most reactive, then secondary, then primary. Exactly opposite. Alkyl halide. Reactivity order we already wrote. Any doubt, guys? If You understand this well, all the point. Now you can write both the steps. We said two steps are involved in this process. So, step one is the divorce. Most important, very slow process, might take 5-10 years also, or even more than that. So, first step is formation of carbocation. Formation of carbocation. And this formation of carbocation is like divorce. This divorce process takes longest time and it can reverse. That's why you will call this step 1 as a rate determining step, RDS. It will decide whether reaction will proceed or not, how much time it takes. Because husband want to have the second marriage, but divorce is taking maybe like 10 years. Not possible. So it is a slow process. Give me a minute. Hello. हाँ, बढ़िया. क्लास लेना था 11:15 बजे तक. फिर देखेंगे, बताऊंगा तेरे तक कर करना. ठीक है, मैं बता दूंगा. घर में काम आवा. कौन से कपड़े? ठीक है. बत- ठीक. So this is rate determining step because it will decide the speed. This is the slowest step I just mentioned, and this is reversible step, and all are extremely important for your concept. As I mentioned in the beginning, whatever story I am telling, morally this is wrong, and I strongly agree with this. But at the same point, what is our main concern? We have to understand the concept because you can permanently expect one question from this topic in NEET, and in bold they always ask. Always means always. Like who wrote last year? Chandana, you had from SN1, SN2 one question in your board.
Yes, sir. For 5
Huh.
marks.
For 5 marks.
Yes, sir.
Exactly.
Yes,
Exactly.
sir. They
So
ask us to do a differentiation table.
differentiation table.
They'll be like,
That,
what is the difference between SN1 and SN2? Give like a proper detailed
oh,
explanation.
that's the reason I gave all these points. How many difference are there? One, two, three. I will mention. So it will help the student to mention the difference. So can you see if you write 7 difference like this, it will be done more than enough for 5 marks,
Yes,
seven
sir.
difference. Huh. Okay, so but all these points are extremely important for in NEET JEE also. I will show in the JEE question. Like it's very popular. Each and every point written here is extremely important. What is the rate determining step, slow step, and reversible step? Got it? So what happened here? You start with the tertiary because tertiary is more reactive. So CS3, this is Br. So Br, or you can take any halogen. Don't write Br, otherwise you will think it is only from bromine. So first thing is it is reversible. See, I am writing the full reversible thing. Extremely important because people make mistake in this. Jordan, tell me when. Hello, hello, Sanjay, बढ़िया क्लास ले रहा था. हाँ, ठीक है, क्लास के बाद बात करता हूँ. Okay, so Jordan, tell me. Last year you used to make mistake in some of the this, and like your marks were cut because of that. Even to Hina, he not mentioning the right thing like slow step RDS, reversible, polar protic solvent,
Yes, sir.
all
I
these
wrote
points.
short forms and all, and yeah.
No, sir, I wrote it properly. I got marks.
Okay. So it is loose step. Again, you have to write. This is rate determining step. You have to write complete. And this happen in the polar protic solvent. You will ask, sir, we are writing neat. Why we are doing this again and again? Because for your exam, you have to repeat and again and again and again revision. It's like revision here. So what happen after this? Carbocation will form. This step name is carbocation formation. And once carbocation is formed, now this can react with anything. So that's why second step is not important. First is second step is very easy. Step two, nucleophile attack. Step two, nucleophile attack. So not so important. Why? Because now it is freely available to react with anything. More important is dissociation. Example, if you take OH negative ion in this case. So what will happen? Same carbocation formed in the first step will react with the OH negative ion. This is the fast step. Irreversible. Remember, irreversible only in one direction, not both. Irreversible. Correct. And there is a formation of this. And you can see here retention of configuration. Configuration is same as the initial configuration. Correct. This is retention of configuration. Retention of configuration. Very important. Weldon inversion configuration and retention of configuration. Okay. If you see reactivity compared to your SN2, in SN2, more the side group, bulky group, they will create steric hindrance. Here, more the group, it is good because they are supporting the process. Okay. That's why when you write the reactivity order in this case, more the number of group, more will be reactivity. So in this case, it will be maximum tertiary alkyl halide of alkyl halide, tertiary, then secondary, then primary. It means halogen is same. Your R group is different. And based on the R group, this is the thing. Or if you write in the proper form, CH3, 3 times, C, halogen, more reactive than CH3 twice, halogen, CH3, CH2, halogen. Okay, so these are again tertiary, secondary, and primary. This is tertiary, this is secondary, this is primary. And this is exactly opposite to the SN2. Opposite to SN2. Because this is more important. If you know one, another will automatically come.
So can you just scroll up a bit, sir?
Yeah. Pratigya, what will be reactivity order of halogen?
Done, sir.
Huh.
The
Pratigya, what will
fluorine
be?
is more.
Iodine will be more. It remains same. Because better living group is always prioritized in the reaction. Ri. Okay, so it will remain same. I will write same as SN2. Why better living group? Faster will be the reaction. Also, you have two important group which is related to the carbocation, and we are already done in the GOC. You know, tertiary carbocation is more stable because of the hyperconjugation, 9 alpha hydrogen. Correct? If you see in this situation, you will have 9 alpha hydrogen. So you will have hyperconjugation. Hyperconjugation. So in this hyperconjugation, because it is like no bond, uh, what is this? What is the name of this? What is the name of this hyperconjugation? Another name? No bond, no bond, no bond.
No bond resonance.
Resonance.
No bond resonance. Yes. No bond resonance. Baker and Nathan effect. No bond resonance. So, because of this no bond resonance, it is stable, and more stable carbocation is preferred. Correct? When you are talking about stability, hyperconjugation is the one effect that provide more stability. Sania, other than the hyperconjugation, which factor will be responsible for a high stability of the compound? Resonance. Sania, resonance is highly stable. More resonating structure, more will be the stability of the
Yes, sir.
carbocation. If you take example CH2, CH, CH2 halogen, this carbon is sp3, and after that you have sp2. This is allyl. Correct? This will be highly reactive. This allyl halide will be highly reactive for SN1. Why? Because of the resonance, it is highly stable. Reason? Due to resonance. Due to resonance. Any doubt? And how do we know? If you remove halogen, then you will form carbocation. This carbocation can easily move, and it can easily move, show resonating structure like this: CH2 positive, CH double bond, CH2. Got it, guys? Resonating structure. This positive charge will shift from the first carbon to third carbon. You can give numbering for the easy, for convenience. So 1, 2, 3. So in the first diagram, you were having positive charge on first carbon, and second diagram, third carbon. Resonance. Two resonating structure, highly stable. Rayan, can we say in the same manner, benzylic halide will be highly stable?
I think maybe so.
Yes, it is. Why? Here you have two resonating structures. In benzylic halide, you have five resonating structures.
Five.
Correct? So AR means benzene ring. CH2 halogen. This is benzyl halide. This is benzyl halide. This is again highly reactive toward SN1, and region is same due to resonance. And here you have five resonating structure, remember. Same situation, five resonating structure, highly stable. Sorry. Let me write this question and then I will ask. Give me a minute.
So can you just show the screen, sir?
Yes, Jordan.
No, so I just wanted to show the screen.
So this is extremely important. Keep benzyl halide and allyl halide, like tertiary carbocation, are highly stable. Reason, resonance, stability of carbocation. Okay. Example. If you see where you will see faster SN2 reaction, and your options are uh, CH3, CH2, Cl, and CH3, Cl. Second one, SN2, smaller size, faster reaction. Example, second, if you see CH3, Cl, and CH3, Br, Sara, which one will be more reactive? Sara,
CH3 Br.
CH3, Br, better leaving group, reactivity order of halogen. If you take one more example, Ryan,
Yes, sir.
1, 2, 3. You have aryl CS2 Br, aryl CH, aryl Br, and aryl CH, CH3 Br, and last aryl, 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 sorry, CH3 Br. These are the four molecules. You have to tell which one is most reactive for both SN1 and SN2.
So
SN2 first.
for SN1, 1 is the reactive,
Hmm.
then comes the 2, then 3 and the 4.
So 1, 2, 3, 4.
Yes, sir. For SN1. Sorry, for
SN1.
SN2. SN2, sorry, sir. For SN2.
1, 2, 3, 4. And
And for
SN1.
SN1, it's opposite. No, sir, same only. Sorry, sir. Because,
Correct?
yes, sir, maybe I.
All of you agree with that?
One minute, sir. I just have to read it again. So for
Correct me, sir.
SN1,
Mm-hmm.
so for SN1, should it be 4, 2, 3, 1?
Yeah,
No,
because
but then
does it not,
steric nature comes in, so I'm confused between the position of 2 and 3, sir.
so is it not
Because AR
tertiary,
and AR are
secondary, primary?
bulky.
Like benzylic, allylic, tertiary, secondary, primary, then methyl?
So what is your sequence?
4, 3, 2, 1, sir.
4, 3, 2, 1.
I mean, not 4, sir. I don't know what 4, but like 3, 2, 1, that much I know.
Can I write like this?
4 to 3, 1 is what I think, sir.
4, 2, 3, 1.
Because of his bulky nature, is willing to give out more stability, that's why.
This is correct. Why? More benzene, more resonance, more stability for SN1. Correct. More benzene ring, more stability, and that's why that will give you the SN1 order. So in fourth,
Yes,
you
sir.
have two benzene ring with one alkyl group also. So tertiary, highly stable plus two benzene ring, more resonance. Here you have two benzene ring, secondary but two benzene ring, highly stable. Why not 4321? In third, you have only one benzene ring. So if you have to compare CH3 and benzene ring is more reactive for SN1. Understood, guys? Anybody have doubt?
Sir, can you again repeat what did you say just now?
More benzene ring, more stability.
Okay,
If
sir.
you see number of benzene ring, 2 and 4 have maximum number, that is 2, 2. Correct? So I will mention the same word. More benzene ring means more stability. So if you see in 2 and 3 more benzene ring stable, but out of these two we have to choose one. Then you have second thing. Instead of more stability, SN1 more reactive. Okay. But if 2 and 4 have same number of benzene, then tertiary is greater than the secondary. So in fourth you have tertiary, and in second you have secondary. Okay, so that's why. So this one will be more SN1 order, activity order. Any doubt?
No, sir.
Anybody have doubt, guys? And you know, SN2 order when halogen is same is exactly opposite to the order of SN1. So 1 will be most reactive, then 3, then 2, then 4. Got it? So simple. Remember one. Remember SN1. In SN1, tertiary is more reactive. Allyl and benzene are more reactive. And SN2 ulta. Done. Okay, guys. So tell me, Jordan, did you learn new example through through this question? Ki yes, how we have to create the difference? Though your answer was already correct.
Yes, I mean, not new example, but then to brought back memory, whatever I
Yes.
lost.
Yes. So tell me, guys, one by one, how is your understanding in SN1 and SN2 now? Anvita,
So
ordering का?
good, sir.
हाँ,
So can you show the
बेड
screen?
पे. या प्रतिज्ञा.
Now I am confident, sir.
ना मोटा आयु वो लग गया देखने में. तो कोई के हाँ नहीं नहीं ओडन का यू बिछाना को नहीं यू दौड़ आया नहीं थोड़ी बुंडा हो जाएगा.
I'm done, sir.
हाँ. यस. ठीक है. प्रतिज्ञा समझ में आया अच्छे से? ठीक है.
Now I am confident, sir.
You are confident. Very good. Barinder, मजा आया?
Yes, sir. मजा है.
Chandana, you were already there last year, right?
Yes, sir.
Understood well?
Yes, sir. Understood.
Then after Jordan, Sania.
Yes, sir. Now I'm confident enough to attempt questions.
Because you get all of you listen, you get a lot of question from SN1 SN2 in every exam. Whenever you have SN1 SN2 chapter like Haloalkane and Haloarenes, you will definitely get this question one or other way. रेहान, ऑर्गेनिक टफ लगती है?
जी सर,
इसमें लगी थी?
पढ़ाया भी तो ऐसा ही है ना सर, कुछ बोल नहीं सकते, नो वर्ड्स।
नहीं, बट अभी इसमें लगी थी इस टॉपिक में?
नहीं।
पहले ये एक्सप्लेन ऐसे ही किया था अपने सर ने.
काश कर सकते थे।
अच्छा, तो ही ना
Yes, sir.
अंडरस्टूड एवरीथिंग.
सर
Yes,
बाय
sir.
द वे,
Understood.
जो SN1 था ना, मतलब ऑनलाइन में पढ़ाया था, मतलब बीच में
हाँ
कुछ छुट्टी हो गया था तो करके,
हाँ
तो अच्छे से कवर नहीं किए थे।
हाँ, वो कई बार ऑनलाइन का लिमिटेशन. यस, तो ही ना
सर आपकी जो
अंडरस्टूड.
SN2 मैकेनिज्म जो रिएक्शन था वो
SN2 मैकेनिज्म रिएक्शन.
जो आप बोले ना समथिंग बाई GF वगैरह वगैरह,
हाँ
हाँ आप ऐसे में बोले.
नहीं नहीं, बस ऐसे मैंने स्टोरी बनाई थी. ये मेरी आई एम प्राउड कि मैंने ये स्टोरी बनाई थी 10 ईयर बैक कि ऐसे ऐसे मैं, क्योंकि इसमें क्वेश्चन आते थे और मैं डिफिकल्टी फेस करता था. सारा.
सर पर आगे थोड़ा देख ले।
हाँ, क्योंकि रिकॉर्डिंग भी हो रही है. या फ्यूचर में आगे देखकर, अब शादी हो रही है.
अब जो समझे सर, हमारा
अच्छा.
हमारा काम था बोलना और हमने बोल दिया।
नहीं नहीं नहीं, ये बस, ये पात्र सारे काल्पनिक है. इनका सच्चाई से कोई लेना देना नहीं है. ऑल द कैरेक्टर आर फिक्शनल.
जी सर।
ठीक है. सारा, अंडरस्टूड वेल?
Yes, sir.
Is chemistry really difficult?
A little bit.
No, this part.
No, not this part.
Huh. Why I am telling, like asking each and every one of you, because we know we can secure through 1 hour session one permanent question, whether it is board or need. So that's the best thing, best deal. It is worth to give time to this. So if you know this reaction based on the nucleophilic substitution SN1 SN2, almost same thing, and for conversion extremely important, the different type of reaction. Okay, I will show you one or two remaining is given in NCRT. I will write each and every reaction, but mechanism is same. Nucleophilic substitution reaction again, but general. In nucleophilic substitution reaction, it means nucleophile again substitute your halogen. Correct? So, in all this situation, you know one common thing. Your reactant is alkyl halide. Your reactant is alkyl halide. Now, this alkyl halide can react with a different thing. Example, first reaction. If your alkyl halide react with NaOH, you know NaX can easily come out, nucleophilic substitution reaction. OH is the nucleophile in this case. So, what is the logically product? Your ROH and NaX. Not only here, even in the next chapter, alcohol phenol ether, you can make alcohol using the alkyl halide. Same reaction. Correct. You can use there also. Same thing is taken in case of H2O. If it react with the H2O, what will happen? You can write H2O in the different form H and OH. So again, product is same, but HX will come out. Nucleophilic substitution reaction, just changing the name or reagent. Everything else is same. Example: if you take NaOR, Sarah, what should be the product? What should be the product, Sarah?
Ether.
Ether, because here OR negative will be nucleophile. Sodium is electrophile because positive charge. NaX will come out and it will lead to the formation of ether and NaX. So tell me, guys, is it logical more or it just you have to memorize everything? We have to just make nucleophile negative part and process will be done. Okay. So next, if the same thing react with NaI, Jordan, what will be the product?
It'll be Ri and NaX.
Correct. And what is the name of this reaction? Hello. Okay.
Swartz? No, wait, no,
Nana
Swartz is for
Nana की बात
Finkelsteins.
जल्दी
Finkelsteins.
तो कर ना नन्ना की तो फिर ब्याह को करो जिंदा जी नन्ना इमरजेंसी इनका काले रमणा गोत है हाँ ठीक ना नन्ना की तो फिर ब्याह को करो जिंदा हाँ yes Jordan, what is the name of this reaction?
Finkelstein, sir.
Exactly, very important naming reaction, Finkelstein. And it occur in the dry ether reversible process lead Chatterley principle work, but in simplest form it is just substitution of like iodine will replace any of the other halogen. It could be chlorine or bromine. Next, Sania, if it react with the ammonia, what will be the product?
Sir, will it be
This make sense?
yes, sir?
Tuhina, if it react with the amine,
Yes, sir.
what will be the product?
Uh, yes, sir.
So what will be the product?
Sir, two hours. Yeah.
Correct.
Yes, sir.
Anvita, what will be the product in this case? Correct, Anvita. What will be the product?
Like 3 hours.
Yes. So what you are doing in every step, you are just making positive and negative ion. Even same thing you can make here, Na positive and OH negative. Same H positive, OH negative. Same Na positive, OH negative, OR negative. Na positive, I negative. Just make positive and negative and then eliminate. The substitution. Got it? Next, Chandana. If it react with the KCN, what will be the product?
Sir, RCN.
RCN. Barinder, if you take AgCN, What will be the product? Barinder,
Yes, sir.
what will be the product? Let me write this name also because you will get in the future also. RCN is known as cyanide or nitrile. You can call it as cyanide or nitrile. Cyanide or nitrile. For another, we will use isocyanide or isonitrile. Pratigya, what is the difference between the cyanide and nitrile? Pratigya, what is the difference between the cyanide and nitrile? Anybody can answer. What is the difference between cyanide and nitrile?
So, one is cyanide is negatively charged and nitrile has no charge.
Kind of, but you have to elaborate more. You are right, but you have to dig out more.
So, nitrile can be considered as the functional group, but uh, not used in SN1 and SN2 reactions, like cyanide is used in SN1 or SN2 reactions.
Nitrile is used in the organic compound. So you will consider the covalent bond.
So, like I said, the functional group.
Yes. And if you take cyanide, then
The cyano
cyanide
group
is
is
the ion.
physics.
Yeah. So I will explain this once again. So if you take cyanide, this is ionic in nature. Okay. But if you take nitrile, then you will always consider this. This will be covalent. Got it? This will be covalent. And cyanide is ionic. Got it? Cyanide is ionic and RCN is covalent in nature. Here, KCN is ionic bond, but in AgCN you will consider covalent bond. That's why bond breakage between KCN and AgCN will not be exactly same. And if it is not exactly same, in this case, you will form isocyanate. And your product will be RNC. Extremely important this name. AgCN and KCN is extremely important for your exam, for your conversion, for everything. Whatever reaction written here, everything is important. And if you understood this, almost same thing will happen in case of nitrite and nitro. So this is isocyanide or isonitrile. But if you have to choose one which is more accurate in this case, then you will say कि nitrile word will be more accurate. it will be more accurate nitrile and isonitrile rather than the cyanide or isocyanide, because formula is exactly same, CN in both, or NC. Ultimately, it is same thing. That's why it looks similar, but there is difference. Okay. Anybody have doubt, guys? So focus on these two, KCN and AGCN. Then, if it react with the KNO2, what will be the reaction? Who is left? Chandana. This is also very important. If you take KNO2, then oxygen will form the bond, and this is known as nitrite covalent bond. And if you take AgNO2, Sania, what will be the product? Simple breakdown, nitro. Really, 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 really important. Got it? So focus on these four examples: KCN, AGCN, AGCN covalent. That's why isonitride. And in KNO2, AgNO2, AgNO2 forms simple nitro. Very important. Very, very, very important. Other thing will be easy except lithium aluminum hydride. Jordan, if you take lithium aluminum hydride, what should be the product? Jordan, what will be the answer in this case?
Sir, he is not in the class.
Is it not? Then Sania, you tell. Jordan is in class, but I think he have network issue. He can't hear us.
You
Yes,
want me to
Sania, what is
call
the
him,
answer for
sir?
this? Yeah. Same Ag positive, RCO negative. If this is the situation, then RCOO, R dash, correct? And GX. Last, if you take lithium aluminum hydride, Tuhina, this is also important.
So he's not picking up.
Okay. So if you take lithium aluminum hydride, what will be the product, Tuhina?
Sir, I'm
Hmm.
not sure. I forgot.
Extremely important because you can't even correlate with
Yes,
everything
sir.
else.
It's
It
the
is simple.
strongest reducing agent or something.
Yes, it is reducing agent, so it always add hydrogen. When it add hydrogen, so this is the product. So I will mention this word. One of the strong reducing agent. If it is a strong reducing agent, it will cause reduction of other by adding hydrogen. So it is adding hydrogen only. Got it, guys? Anybody have doubt in this nucleophilic substitution reaction? Anybody have doubt?
No, sir.
So small part is left, only two things. One, reaction with metal, Grignard reagent, and dehydrohalogenation reaction. Other than that, In haloarenes, there are few reasons why haloarenes do not happen easily. Electrophilic substitution reaction, 5 reaction universal, and then application. That's all. So we are done with the majority chemical properties because remaining are like one liner. Dehydrohalogenation, just 5 minutes. Then in case of Grignard reagent, 2 minutes. Woods fitting and fitting reaction are important. And after that, reason why haloarenes do not react like haloalkanes. And ultimately, electrophilic substitution reaction like nucleophilic. So, is this enough? Because I said 11 o'clock. It's almost 11 o'clock. Got it? So, what you have to do is make sure you write, what is the next class time? You will have on time. Okay. So, next class will be at 12 o'clock. Yes, it will be on 12 o'clock and we will start ray optics. What you have to do is quickly revise this. Quickly revise this and solve only 10 questions from this topic. Who left? Ania, Ryan, Tahina, Sara, Chandana, Varinder, Pratika, Anvita.
There was
Anvita.
a network issue.
It's okay, Jordan. So,